QSO Today, episode 451, Alan Johnston KU2Y. This episode of QSO Today is listener-sponsored. Only you can keep the QSO Today podcast coming to you every weekend since 2014. Please become a listener sponsor monthly or annually by clicking on the sponsor banner on the show notes page or at the top of the QSOtoday.com webpage. Our website, as I just said, is at QSOtoday.com, and we are active on Facebook and QRZ. There is a subscribe button on the bottom of every show notes page to subscribe to our weekly notifications when new episodes are published. Welcome to the QSO Today podcast. I'm Eric Guth, amateur call sign 4Z1UG, where I demonstrate the diversity and relevance of the amateur radio hobby and its impact on society by interviewing ham radio operators, many of whom played vital roles in shaping our technology through the amateur radio hobby. And while many people might say, ham radio, do people still do that? This podcast demonstrates through in-depth interviews just how amazing, diverse, and dynamic the amateur radio hobby continues to be. I'm not in Dayton for Hamvention this year. I had a project before the COVID-19 pandemic called The Great American Songbook Jerusalem, where I produce concerts and perform with a group of professional musicians the classic and popular songs from stage and screen. I have resurrected the songbook and will be performing it on May 30th in Jerusalem. Hopefully, with great reviews, we can sell it to other venues around Israel. Like everything else I do, it's my sometimes very expensive university to learn new skills. Producing a live professional concert has me learning a lot. Just like ham radio, it keeps my brain in gear. Alan Johnston KU2Y has a continued interest in amateur satellites since his early beginnings in ham radio over 40 years ago. Now AMSAT's VP of Educational Relations, Alan reaches out to educate the general public about the intriguing world of amateur radio satellites and satellite technology using Cubesatsim, a live classroom simulation of satellite communications. Furthermore, he turns to high-altitude balloon launches as a practical, hands-on approach to bringing amateur payloads closer to space, thereby affording opportunities for tangible experience and simulation. KU2Y is my QSO Today. KU2Y, this is Eric 4Z1UG. Are you there, Alan?
Yes, I am. It's great to meet you virtually here, Eric.
And it's a pleasure for me as well today, Alan. Thanks for joining me on the QSO Today podcast. Can we start at the beginning of your ham radio story? When and how did it start for you? And we're going way back if we can.
Sure. So what happened to me was at one point my father came to me and said, hey, let's get our ham radio licenses.
And how old were you?
I was a teenager.
Were you showing any interest in electronics or technology before that?
Oh, yeah. I was building things in electronics. I was working on early computers of the day.
When did that start for you? Were you one of these kids that experimented with electricity when your parents weren't looking?
Not quite, but I did build a lot of things, and I had older brothers that were building things like synthesizers and computers and things like that. So I had a lot of exposure to things back then. I was also extremely interested in the space program. I have a lot of memories of the Apollo program and the space shuttle, and in fact, one of my earliest memories is of the moonwalking.
So I'm assuming that you're not 50 yet?
I'm over 50.
Oh, you're over 50. Okay, so you would remember perhaps the first moon landing?
Mm-hmm.
Those were amazing times. Before your father came to you to be interested in ham radio, did he also make the offer to your brothers? Or was this something he wanted to do with you?
Well, so he was recently retired, so I think he was kind of, looking to do things. And I think it was something he always wanted to do. He had a couple of friends when he was growing up who were hams. I think he just thought it was an opportunity to do it, and so we did it together.
What was the hometown?
I was living in New Jersey at that point. Pittman, New Jersey, next to Glassboro, where Rowan University is and where I taught in the past.
So you had an interest in electronics. Your father, as a teenager, so you must have been in high school, comes to you, and you got your licenses together at that time?
We did. We went to classes at a nearby high school, and of course we had to learn Morse code back then. We both got our ticket.
And what was your first license, and when was it?
I started off as a general, so my first call was N2DES.
That's actually kind of amazing that you actually took that first step into general. So you were at 13 words a minute code speed?
Yeah, well, so back then, novice, to do the novice test was just administered by a fellow ham. It wasn't administered officially. So I basically went to the official licensing test. I think it was at some kind of a ham fest. And so I couldn't go for the novice.
Oh, because they weren't testing for the novice there. But how did you get your code speed up to 13 words a minute without being on the air? Did you use records or something like that?
Well, we did practice. I actually built a little Heathkit keyer, and it had a mode in it where it would just transmit signals to you using its speaker. And so I would practice and copy that.
So your first license was a general class license, and what year was that? Do you remember?
82, I think.
You're an old timer. You're past quarter century club, right?
Yes.
So what happened after that? Did this interest in electronics and ham radio play a part in the choices that you made for your education and career?
Oh, definitely. Yeah, I mean, I became an electrical engineer, and I eventually got my doctorate in electrical engineering. So it was definitely a key part. And also, very early on, I discovered amateur radio satellites. I think I found an old AMSAT journal, like at a ham radio store, and I was like, amateur radio satellites, what the heck is this? You know, the notion that that people would build and launch satellites into space, who weren't governments or the military or whatever, was pretty amazing.
Let's back up, though, because I don't want to get too far ahead of ourselves here. You actually did some college in Australia?
I did. So I was actually born in Australia, in Melbourne, Australia, but my family moved to the U.S. To New Jersey when I was very young. So I grew up and went to school in New Jersey, but then I went back there, finished high school, and then did my undergraduate at the University of Melbourne. So I got to live in Melbourne for 5 years.
Did you go back to Australia to go to university?
Yeah.
To kind of reestablish residency?
Yeah, I had to basically take the standardized tests to get in. It was great, and I got to get to know my cousins and all that, because all my immediate family was in the U.S., but all my other family was still back in Australia. I did some operating there. I was VK3 DQA while I was there.
And you got to meet many of the other Melbourne hams?
I did. I got to meet some. Yeah, it was fun.
Okay, so you did your undergraduate work in Australia. You came back and you did graduate work where?
Yeah, so I worked in industry for a few years, and then eventually I got my PhD at Lehigh University, which is in Pennsylvania here.
And what did you do in industry before you went back for your PhD, or while you were doing the PhD?
I worked in the IT, actually the IT department for DuPont, the big chemical company. So I was living in New Jersey, working in Delaware. It's actually a number of really big ham clubs in Delaware back then.
Were you a member of them?
I wasn't a member, but my friends were, so I used to go to their meetings and things.
Is this where you discovered satellites, or did you discover satellites when you were in Australia?
No, it was pretty much right after I got my license, because after we both passed the test, we then needed to get some equipment. We needed to get on the air, and that's when we started visiting the stores. And I think that's when I came across, I learned about amateur radio satellites. That kind of became my goal. I did HF operating as well.
What was the first rig, Alan?
I had an ICOM 730, so it was a very early transistorized rig.
Was that ICOM 730 shared with your father, or did he have his own rig?
He never did too much operating.
Oh, so he got the license and he kind of let you take over.
Yeah.
And when you went to Australia, did you take the rig with you?
We did. Some of the time we had it there. Some of the time I just used the Melbourne Uni had had a ham club, so I occasionally used their station.
So you have the book on satellites. How did the satellite ham radio thing for you develop?
Yeah, well, I just decided I was going to do it, and so I had to read up on it. I had to build the antennas needed to do it, and also I wrote my own satellite tracking program, just to tell me when it was coming over the horizon. So my Commodore 64 would spit out the basically the dates and times and azimuth and elevation. Eventually, I did. Back then, I was just doing CW on the satellites because there was no computer Doppler control or anything. So sideband was pretty difficult with the frequency shift.
Now, in those days, were amateur satellites LEOs? I mean, were they in low Earth orbit, or were they actually running higher?
It varied, but back, I guess Oscar 8, AO8 was the one that I used the most back then, and it was in it's probably higher orbit than today, because I noticed I think it's still in orbit today. It's inactive, but it's still up there. But it wasn't a really high orbit.
But it's high enough that its orbit hasn't degraded.
Right.
And do amateur satellites actually degrade and fall into the atmosphere?
Oh yeah. There's one happening in the next day or so. XW2A, one of the great Chinese amateur radio satellites that I've used before. It's about to re-enter. It's kind of a fun thing. Hams try to get like the last telemetry from it. Try to get the last signals from it before it re-enters.
As it's re-entering, perhaps. So you can actually hear it burning up in the atmosphere as the last signals are going down? As it signal fades into the sunset?
I think it just shuts off abruptly.
How many amateur satellites are still in orbit right now?
You mean like active ones?
Maybe it's two questions. Maybe the first question is, how many active amateur satellites are there right now? And how many satellites are inactive and still in orbit?
Yeah, well, there's a couple dozen that are operational now that people are using. Many have decayed, but there's also plenty that are still up there. So, I guess the Oscar number, you can kind of tell how far we are in history based on the Oscar number, with Oscar 1 being the first. I guess we're up to about 120 now. So, yeah.
In every amateur satellite, whether it's a Chinese satellite, it becomes an Oscar?
Any amateur radio satellite can get an Oscar number if they want it. All they have to do is have a verified reception of their signal. So they need to transmit and have somebody receive it. And then they just need to contact AMSAT and request an AMSAT number. So lots of groups do, but not all of them do.
So that means that if there's over 120 Oscar numbers, that there actually may be more ham satellites that are not.
Oh, for sure. Well, like the Russian series, I guess RS-44 is a very popular amateur radio satellite today. I remember, I think RS-16 and RS-17, that back when I was active years and years ago, those were the ones. So yeah, Russians have launched plenty, and these days China is launching a lot as well.
Do the Russians and the Chinese take a different approach in terms of how their transponders work, in terms of whether it's CW or data? I mean, do they have preferences over what American satellites do, for example? Is there a remarkable difference between the way they operate?
Not really. No, they're fairly similar. Some are what are called linear transponders, where there's a whole they just take a whole receive band segment and then they retransmit that whole segment back to Earth. And so with that, you can have multiple contacts all happening at the same time. Some of them are FM satellites, where it's just a single channel, basically. So it's just a single channel uplink and a single channel downlink.
Crossband repeater.
Exactly. Yep. And there's also digital ones too, where you have to send like an APRS packet or some other formatted data up to it, and then that gets processed, stored, and retransmitted back down.
Are there satellites that are, say, store and forward? So if I wanted to send a message to a specific ham, can I somehow catch it and upload to the satellite as it flies over, and when it flies over on the other side of the world, it can drop a message to someone else?
It has been done before, yeah. I'm not sure any of the current ones do that. Although I haven't, there's a popular one right now called Green Cube. I haven't used it yet. And it's also a very high orbit as well. So I know people are making very, very long distance contacts with it.
So what little I know about satellites, you uplink on UHF and downlink on VHF or vice versa. But are there any amateur satellites that have microwave transponders?
Yeah. There's that's kind of the future, is moving to the higher bands. The current generation of AMSAT satellites are the Fox series, but the next generation is known as Golf. Their transponders are known as 5 and dime. So basically, it's 5 gigahertz uplink and 10 gigahertz downlink.
Oh, that's great. So you could use like a cable TV L&B for receiving.
Yep.
And are you doing that? Are you preparing your Earth station to be able to do that kind of work?
Not yet, but I certainly will before Golf is launched.
You mentioned Oscar 8. When you first started doing CW on the satellites, did you do that with a hand antenna out in the yard? I guess if you're right-handed with your key, you're holding the antenna in the left hand?
Yeah. So I built a type of antenna called a cross turnstile. It's basically two dipoles phased to give you circular polarization, because satellites are always spinning in space. So you don't want to transmit with either vertical or horizontal polarization, otherwise you're going to get big fades. So it was just a simple cross dipole with a reflector. I think my reflector was made out of chicken wire, basically just a ground plane. And it was built using, I think it was built using like a 2x3 piece of wood. And I basically propped it to aim in the rough direction. So at the start of the pass, I would have it, pointing south or whatever. And then during the middle of the pass, I would move it so it was pointing kind of up. And then for the latter half, I would tip it over. So it was very simple.
But it worked.
Yeah, it did work. Yeah, the mode I used was, I think it was 2 meter uplink, and it was 10 meter downlink. So I had a full wave loop as my receive antenna on 10 meters. And actually, some of the satellites today have uplinks and downlinks on 15 meters and HF bands. So there's a lot of variation.
Really? I didn't know that.
Yep.
And what is your favorite mode of operating satellites now?
Oh, these days I like, with full computer Doppler control and all that kind of thing, you can do sideband, so you can talk to people. And if you use the linear satellites and some of the high ones, you can actually have a conversation. You can even exchange names and where you're located and things like that, which counts as a long contact on satellites. If you use the linear satellites, people are just exchanging call signs and grid squares, and it's very frantic
because of the short amount of time for the pass.
And it's single channel, so everybody who's receiving the satellite, they all have to take turns basically in order to make contacts. Whereas on the linear satellites, you can have 10, 20 different contacts all happening at the same time.
Let's switch gears for just a little bit here. Are you still the VP of Educational Relations at AMSAT?
Yes.
It's my understanding that part of that responsibility was to reach out to primary through university age students to kind of teach them about satellite technology, maybe ham radio based on that. Could you talk a little bit about what AMSAT's role is in education and how perhaps it might impact STEM?
Sure. Yeah. So AMSAT is basically formed as an educational not-for-profit. If you go back to our original organization over 50 years ago, and we've been launching amateur radio satellites since then, and we've also been doing educational outreach, and sometimes it involves outreach to universities and helping them build satellites, have them design components and things like that fly in our own satellites. But we also try to do outreach, as you say, just STEM, right? Science, technology, engineering, math, outreach. And one of the projects that I've been involved in is known as the CubeSat simulator. And that's a way of basically putting satellite and radio technology into people's hands. A satellite is a thing that flies way overhead and is only overhead for, a few minutes each day kind of thing. Whereas if you can have a functional model of a satellite in the classroom, you can do a whole lot of things with it. And you can teach a lot about amateur radio and about satellites and about STEM in general. So that's kind of been my focus lately.
So what does Cubesatsim look like in the classroom? Does AMSAT provide an instructor that goes to the classroom? Does it come as a kit with a workbook and videos? How is it implemented in the classroom?
Yeah, so it's a bunch of different ways. So some hams volunteer to go to events, go to classrooms, and basically give presentations and demos. When they do that, they either do it with a CubeSat simulator that they've built themselves, or we have AMSAT has loaners, and so AMSAT members can basically request it for an event, and I ship it to them, and it's basically fully assembled. It's got a ground station, and all I do is just unpack it and go through things. Also, some teachers request it as well. Teachers that teach engineering and or who do amateur radio or CubeSat clubs at high schools and universities. Some of them request it, and so I ship the units to them. Other classes build it, so they basically just the whole CubeSat simulator. It's fully open source, so you can download all the software on GitHub. You can download the Gerber files, print the circuit boards with the bill of materials, order up all the parts, and get soldering. You can 3D print the frame, right, which is just plastic. For a couple $100, you can basically build your own. So some classes have done that. My students at Villanova University, where I teach, we just finished a class where we built 7 CubeSat simulators in the course of the classroom.
And that's because of the economy of scale that comes from printing boards and making all the parts?
What, the 7 you mean, or the...
Yeah, you buy 7 because, you got to buy 10 boards anyway. You might as well... Is that part of the reason, or you actually had a demand for 7?
It's a matter of wanting to give the students hands-on. So we basically had... how many classes did we have? 2, 4... We had 6 classes altogether, and we basically broke each class in half, and then we assigned different subsystems to teams of students, 2 or 3 or possibly 4, and so they built and worked on one aspect of the satellite, soldered it, tested it, and then the students came together and integrated it and got it all working. So.
Do you have any numbers in terms of the number of students who have been impacted by Cubesatsim across America? Do you have any sense of how much penetration you've actually gotten with your program? Yeah,
I don't know. I mean, it's still early days, really. We've only been doing it for a few years. We've AMSAT actually. You mentioned about when you order the circuit boards, 10 is like the minimum quantity. And so at AMSAT, we actually order the boards, and then we offer them on our website, so you can buy just one set of boards. And we also put the surface mount. There's a couple of surface mount components, and so we pre-install them because surface mount soldering is a little trickier than through-hole soldering. We've sold quite a number of those. We've probably sold over 100 sets over the years, and not all those would have been built. We all get excited about a project at the start, and it ends up in a drawer. Maybe it gets completed years later. So yeah, not all of those would have been built, but quite a few of them have. And certainly CubeSat simulator ends up going to probably about a dozen events per year altogether. So it's It's a decent number.
Because it's a Cubesatsim, it's a simulator. Does it have live radios on board?
Oh yeah, yeah. It transmits real telemetry on the 70 centimeter band, so 434.9. So my simulator. Oh, actually, it's shut down. I wonder if it ran out of battery. I powered it up earlier.
Is that frequency ISM? It's the same frequency that garage door controls and stuff like that are on?
We chose it because it's in the ham band and it's in the ISM band.
So you don't have to have a license to use the control station, but the control station is also probably milliwatts and not watts, right?
Exactly. Yeah, it's super low power, so it works within a classroom. And if you want to say fly it on a balloon, then you need to do some things differently.
Right, with a licensed ham.
Mm-hmm.
Okay, so what kind of things can you control on the Cubesatsim with the control station? What does it do? It transmits real telemetry in the same exact formats that real satellites do. So things like APRS packets. So basically packet radio. It transmits those. It does frequency shift keying. It does phase shift keying. It does slow scan TV. It has a camera. I don't know if you can see the little camera built in there. So it has a selfie mode where it'll basically take photos every 30 seconds and transmit them as slow scan images. And with the right software on your ground station, you can decode it. It also does CW as well. And the thing is that in order to decode it, you need software, right? You need like a radio, which is typically a software-defined radio. You know, we really like these RTL SDRs, right? Just super cheap. You know, these like $30. You know, it's just amazing. For a radio that works from like DC to blue light almost, right?
Exactly. It's incredible.
Up to 2 or 4 gigahertz, something like that?
This one goes up to like 1.8.
1.8, almost 2 gigahertz.
Only, yeah.
Only, yeah, that's pretty cool. Do you have other like management functions of the satellite, battery control or power control or things like that?
So right now we do not yet have actual, you don't send commands to it. Basically the way you do commands is it's got a little push button on it, you know, which is not typical for a satellite. You know, it's not. But it's good for a classroom to basically you change the mode by pressing the button and holding it, and then it will switch between the different modes.
It has solar panels on it, so it can charge itself while it's sitting on a desk in a classroom.
Correct. If now to really charge it, you need sunlight.
Right.
But in just a normal room, you'll get voltage off of these solar panels. They're basically just 5-volt solar panels. So you'll see those voltages. If you put an LED lamp in front of it, if you shine it right on it, then you'll get a couple of milliamps of current. And so some of our experiments involve doing that, because if you put it on a turntable and make it rotate in front of a light, you basically get the same kind of telemetry you get from a satellite that's spinning in space. And you can determine things like what its axis of rotation is and what the rotation rate. You can basically deduce all of that from the telemetry. And we use, for instance, a piece of software called Fox Telem, and that's the same software that AMSAT uses to get telemetry from its Fox series of satellites. And so if you set up your ground station for your CubeSat simulator, in order to receive real satellite telemetry, all you need to do is switch to a real antenna and tune in at the right time. Obviously, you need to run your tracker to figure out when the satellite is going to be flying over, but you'll basically receive the information the exact same way. And many hams use it as a trainer to do things. Hams use it to practice for when, for instance, the ISS, the International Space Station, they have slow scan TV events a couple times a year where they just transmit continuously images. And you can use the CubeSat simulator to basically test out all your software and get it all ready and make sure. And that way, when they announce the the event, you just switch it over to your outdoor antenna, and now you can receive it.
So you have a market for hams who are not children in the classroom, but you actually have ham clubs and groups buying Cubesatsim as a training module for becoming satellite operators?
Yes, and in fact, my QSO Today presentation that I did earlier this year, it was basically about how the CubeSat simulator can be your way to get introduced to real satellite telemetry. And you can learn to use all the software, you can learn to interpret it and get comfortable with it. And then all you need to do is switch to an outdoor antenna and you can start receiving the real thing. And it's much easier to do it that way, because otherwise if you're just setting up and you've got new software, a new antenna, you're not sure if your tracking software is right, and you get all excited and for 12 minutes you get nothing, and then you're like, okay, what went wrong? You don't know what it is. So this is a way of making it so people can transition to it.
And now this mid-show break. You can keep the QSO Today podcast commercial sponsor-free by becoming a listener sponsor yourself. For $10 a month, or save 20% at $100 per year, you can become a listener sponsor. I'm now recording the QSO Today podcast as video interviews that are available only as a benefit to listener sponsors through our QSOTodayCommunity.com website. As I develop the sponsorship tier, I will add bonus content for listener sponsors. The benefit of listener sponsorship as an alternative to commercial sponsorship is that commercial sponsors influence the content and comments in the podcast. Commercial-free allows a greater degree of freedom to discuss any ham radio subject without commercial consequence. I have eliminated all commercials in the QSO Today podcast from episode 445 on, with the exception of the Ham Radio Workbench podcast, as I think it is a serious asset to a well-rounded ham radio education. I'm not using Buy Me a Coffee or Patreon anymore, but my own system for managing the community that could form out of the podcast. I direct you to the sponsorship section of the show notes pages beginning with episode 444, where I list all of the contributors to the podcast since 2014, including sponsors, donors, and hams who have paid for the transcriptions. There is a new section where I list the most recent sponsors and donors over the last 30 days. This list is generated automatically from my membership system. This week's new listener sponsors are Robert Culver, VK5RC, John Ruciano, NG0Z, and Jeffrey Shirker, KM6LFY. Listeners who made donations this week are Joel Holbrook, AL7PQ. There were anonymous donors as well, and we appreciate their contributions without mentioning them by name. Our funding model is now value for value, where you trade with me your time, talent, or treasure that you think values the benefit of the QSO Today podcast to you. If sponsorship is not your interest, then you can make any size donation to the podcast by clicking on the donation button on the QSO Today podcast website at QSOtoday.com. There is a slider that you can use to adjust the amount of your donation. If you want to make your donation monthly, click on the recurring donation box. It is the recurring donations that keep the lights burning here. I want to thank everyone who has contributed and will contribute to my effort to create this oral history of amateur radio since 2014. It will eventually all be in the public domain for hams in the future to enjoy. Be sure to become a listener sponsor or make a donation today. And now back to our QSO Today. I've looked at a lot of presentations from the QSO Today Virtual Ham Expo. I think we now have over 400 in the library. It's my understanding that once you kind of master the skill of being able to take telemetry off the satellite, there are oodles of non-ham satellites that also have telemetry. Is that right?
Sure.
And you've gained this expertise now that perhaps you might even be able to take, say, weather images off of government satellites and things like this.
Definitely, yeah. It definitely gets addicting. There's also a group of hams who like to receive the early packets from newly launched CubeSats. So there's a few that are going to be launched in the next couple of days from the ISS, and basically people get ready and they want to receive the first packets from it, it's actually really important for the developers of those CubeSats because the first couple of data packets will tell you a lot about the health of your satellite. It tells you, what state the battery's in. Are the solar panels working? Is the transmitter working? What are the temperatures like? And so getting those initial packets early on can be critical in extending the life of your CubeSat. And fortunately, there's a whole community that loves to do this. There's a whole network called SatNogs. I don't know if you've ever heard about that before.
No, but why not?
It's kind of fascinating. It's basically they're basically receive-only satellite ground stations built just using Raspberry Pis and RTL SDRs, but it's fully automated. And so you just install the software, put your antenna up somewhere, and then everything else just happens through the web. And there's thousands of these stations all around the Earth, and people go in and just program them and say, I want to listen to this satellite. And it'll give you a list and it'll say, well, you could listen to the satellite on one of these, 400 stations in the next 2 days. And you can pick them and record them and then go back and listen and decode the telemetry and see what it is. It's really kind of fascinating.
So you say that CubeSats will be launched from the ISS. Now, the first picture that could come to mind is they open the hatch and they shove them out the window. I'm sure it's more than that, or to put them into some kind of elliptical orbit that they have some use or some lifespan. How is that done from the ISS, or is it done on the way to the ISS?
Yeah, well, all different ways. There are videos on YouTube of cosmonauts launching CubeSats, and they basically say, and it's like, okay, you ready? There it goes, because it totally works. Once you're already going 18,000 miles an hour and you're already in orbit, you just need to throw it at 18,020 miles an hour, and it will go into orbit for you. So that's been done.
But they don't have engines. So, however, the cosmonaut's throwing arm is kind of what determines whether it has a good elliptical life.
Yep. Actually, some CubeSats these days do have propulsion. So propulsion in the past used to be basically chemical, right? You'd have to have tanks of, some kind of a gas or, to do. But these days, electrical propulsion is becoming popular. So, in the future, even small CubeSats will be able to maneuver. They will be able to boost their orbit, avoid obstacles and things like that in the future. So that's definitely coming.
What would be an electrical propulsion in space?
Like Hall effect and other types of things. Yeah, there's just some very interesting little engines being developed.
That'll run on 5 volts or whatever the battery is. Oh, that's pretty amazing. Okay, and when a cosmonaut launches a satellite, do they actually bring the ISS or the space station into a lower orbit so that they can avoid the space junk from hitting them in the future?
No, but they just throw it down.
Oh, they throw it down. Oh, okay. Well, that's clever. And what about the risk of collision? Obviously, the world is huge, and the space above the world is huger. Is there a risk of collision of CubeSats?
Yeah, I mean, it's a bigger problem for the bigger satellites. But yeah, these days, collision is a real thing. And the Space Command actually notifies operators of satellites. They'll be like, hey, your satellite is going to come within, 1 kilometer of this other one in 4 days' time. And so operators that do have propulsion, they can take avoiding action. But it is becoming more common.
Is there an air traffic control that could say, well, we're warning you that you're going to come within 1 kilometer. We suggest that you go up, go down. I mean, do you have that kind of resolution in terms of being able to avoid collision?
Yeah, not yet, but who knows where we'll be in the future.
Oh, okay.
With these constellations, right? I mean, companies like Starlink, right? They're launching thousands.
Isn't that supposed to be 24,000, something like that, satellites at some point?
Yes, and there's dozens of other companies planning constellations as well. So the number...
And what does that look like? It seems to me that it looks like you have to be very careful now to go from the Earth to the ISS unless it's below. Is the ISS below these constellations or are they above it?
It depends. Some are below, some are above. Yeah, it's getting crowded out there.
Like the 405 freeway in Los Angeles, perhaps. The Cubesatsim sounds amazing, like an amazing tool for getting going. Do you have any advice or best practices that you might recommend to this audience on how they might get started either with Cubesatsim? A best practice meaning that most people could go to the website and download all the information and think that they've got everything, but with all of this experience under your belt, it seems to me that perhaps you can save some headache and heartache.
Yeah. Well, I don't recommend it as like a first soldering project. Okay. So if you've never soldered before, buy yourself a little blinky light or buzzer or something and do your first soldering project with that. That's what we do with my students. I basically take freshmen electrical and computer engineering students at college, and some of them like they might have done like robotics in high school, so occasionally some of them have done soldering, and occasionally some of them have used tools and things, but for the most part they haven't. They've just been students their whole life. They've just worked with pencil and paper and calculators. And so we do just an initial soldering exercise of a couple of weeks where they just, solder the LEDs and the resistors and the battery holder, and they kind of make their mistakes, that way. But if you do have basic soldering skills, then you can definitely build it. You do need to have access to a 3D printer to make the frame. You can also send it off. There's places that will print it for you on demand. The only other thing is that since the COVID epidemic, the sort of global electronic supply chain has been pretty difficult. We've had to change a bunch of things because different parts just go out of stock, and we don't know when they're coming back, kind of thing.
I happen to work with a couple of electronics manufacturing companies, and there's no end to the headaches here in terms of the supply chain problems.
It's crazy. I mean, you hear stories about engineers who they have to redesign something, but they won't even start redesigning until they've acquired all the parts for production. Only after they have every part they possibly need will they actually start designing, because otherwise they'll just waste their time. Because if they design assuming they're going to have these parts, chances are one critical one is not going to be there, and they'll have to just start from scratch again.
I see that happening also. In fact, what I see also happening is that you start thinking of these microprocessors, memory chips, things like this, as commodities like gold and silver, right? I mean, you could almost bank this stuff and know that at some point you'll be able to sell it at an amazing profit because it's unobtainium, right?
Yep. No, and the other thing is you see the prices go up as the demand gets, as the supply falls, the prices go up. And then there's another unfortunate thing that kicks in where fake parts start to appear, and companies manufacturing them basically stop doing quality control. Instead of they might have 20% failures when they manufacture. Well, why throw away that 20% when people are willing to pay for them? So they just ship all of them, including the failures. So it really becomes difficult. So that's probably my biggest caution, is just you need to have a bit of patience, and don't assume that you'll just instantly be able to get every part on the bill of materials and have it arrive in 2 weeks so that you can start building it, because unfortunately things are more difficult than that right now.
Do you see even more exciting development in ham radio satellite technology coming up? I think you mentioned the 5 and dime. What do you think that's going to look like, and what's coming beyond that?
Yeah, so the cool thing, as you go to higher frequencies, you have a lot more bandwidth to play with. Instead of having kilohertz of bandwidth, you have megahertz of bandwidth to deal with. So you can do all kinds of interesting things. The other thing is that we're looking at in the future having amateur radio, for example, on the moon, or on rockets and ships that are going to the moon, right, such as the Gateway and the like. So, so ham radio is going to kind of go beyond low Earth orbit in the future too. So it's going to be pretty interesting.
So we'll have enhanced EME.
Yes, EME with help.
With help, right. Sounds very exciting. In our hemisphere, in Israel, we're under QO100, which is the Qatari Telecom-based geosynchronous satellite. I think we have a 2 gigahertz uplink and a 10 gigahertz downlink, but we have a whole band there. It looks like the 20-meter band in terms of the amount of spectrum that we have. Do you see any geosynchronous possibilities for the Western Hemisphere?
It's always possible. You just have to get really lucky, or somebody needs to have, a couple $1 million that they want to help out with. It's really just a matter of money and or getting extremely lucky with the right friends in high places, which is what happened with QO100.
So does that mean that there are already satellites in geosynchronous orbit that have the capability of creating transponders in the amateur bands on the fly, or with some programming or something like that? Or is QO100 just so new that they were able to take advantage of a broadband radio?
Yeah, I mean, if things in the future are going to be more like QO100, and the sort of model with QO100 where hams basically designed it, but it was built by the commercial satellite builder. It's unlikely that amateur-built hardware would get integrated with a $100 million satellite that's going into orbit, because what if our board blows it up or does something bad to it, kind of thing. So that sort of model where hams design it, but it gets commercially built and integrated into a system. I think that's kind of the model. But because geostationary, it's so expensive. It's expensive to get there, and it's expensive just to own the real estate, but basically to have the right to operate your satellite and the spectrum there. That it's extremely valuable.
You have to buy a spot and park your satellite there if it's in geosynchronous.
Yep.
Who controls that? I mean, that's some international convention, but how is that decided?
Yeah, I think I don't know. I'm not sure if it's through the ITU or not, because the ITU used to regulate everything relating to telecom. But there are definitely standards bodies that allocate the slots and also the spectrum needed, so that you don't have these satellites bumping into each other or transmitting on top of each other. You don't want to have a lid but geostationary there, messing everybody up.
Are amateur radio satellites affiliated with AMSAT, or maybe not, are those also frequency coordinated, similar to the way that you'd coordinate repeater frequencies in a city?
Yep. Yeah, the International Amateur Radio Union does the coordination. They're sponsored and supported by AMSAT UK. So if you go to AMSAT UK's website, you can look at the list of all the ones that they've coordinated and the like. So it's kind of interesting. You can see what amateur radio launches are coming up in the future. And in order to justify an amateur radio spectrum for it, they have to explain what the purpose of it is and why it's good for amateur radio, right? Why it's advancing the radio art or education or something related to that. So it's pretty interesting to read those, and not all of them get approved either. Sometimes people say, "Oh, I just want to downlink my data," and it's like, sorry, that's not a good use of the amateur radio spectrum. Just you should get an experimental license from the FCC rather than an amateur radio license for your satellite.
And an experimental license would mean then that they would be using frequencies outside of the amateur radio band?
Outside, or sometimes even inside, because it's all, the sort of 70 centimeter is shared amongst a lot of different users. But the point is, if your mission really isn't an amateur radio mission, where it's advancing the radio art or, education relating to it, then you really shouldn't be, getting an amateur radio license for it.
I want to take a minute to tell you about my favorite podcast, the Ham Radio Workbench Podcast, with George, KJ6VU, and now joined by Rod, VA3ON, Mike, VA3MW, Mark, N6MTS, and Vince, VE6LK. Every 2 weeks, George and company offer up a status report on the many amateur radio projects on their workbenches and explore projects on their guests' workbenches. This group is project active and prolific, covering many technical areas of amateur radio. So the next time you want a deep dive into ham radio electronic project building, or to learn about technology, tools, test equipment, construction techniques, and the rest, listen to the Ham Radio Workbench podcast, available on every podcast player and channel. Use the link in this week's show notes page to get to the Ham Radio Workbench podcast directly. And now back to my QSO. Do we have amateur satellites that are sharing frequencies at the same time that they're in orbit?
Yeah.
Like a community repeater, different PL code, something like that?
Well, actually, the Israeli satellites, Tevel, there's a whole series of Tevel ones that actually they just recently were activated. People have been using them over the past few days. But I think there's 6 of them. They were basically 6 pretty much identical Cubesats, and they're they were all launched together, so they're in a similar orbit, and I think they all share the same frequencies. The only way you can tell which one it is if you decode the call sign, and you're like, oh, that's Tevel 4, that's Tevel 6.
What would be the advantage of launching 6 satellites together? It doesn't seem to me that there would be an advantage unless you wanted multi-channel communications on a satellite pass.
Yeah, I'm not sure what their primary mission was and why they did that. I can't remember. It's a few years ago since Tevel was launched.
Or maybe it's like a frequency hopping spread spectrum where they're sending their messages through 6 satellites at the same time so that you can't decode the messages.
I don't think so, but you never know.
Let me ask you, it's my understanding from looking at your bio that you're an expert in SIP. Were you a pioneer in SIP? Could you explain, first of all, what SIP is?
Sure.
Because I think we all use it every day, but we don't maybe realize that we're using it every day. Could you talk about your role in SIP and how that played out?
Sure, yeah. So SIP is Session Initiation Protocol. And a protocol is basically an agreed upon standards that that computers use to exchange messages with each other. So yeah, back in the early days of voice over IP, I got involved in through standards bodies and also through industry, and I got to make a contribution to that work, because if you go back 30 years, people didn't believe the internet existed, but it was just email and things like that. And people didn't really believe you could put real-time media on it. They were like, no, there's going to be too much jitter and too much delay, and you'll have packet loss, and it's just not going to work. But people believed that it would work, that we just needed to keep going with it and engineer it better and develop the protocols. And so sure enough, that's where we are today. But yeah, Session Initiation Protocol, it was an IETF standard. That's the Internet Engineering Task Force. And so I was one of the co-authors of the specification. So basically writing the rules for how it worked and how calls were set up and how different types of media were negotiated in real time. Use a whole series of messages, kind of like a handshake going on. And initially, it was just between big enterprise servers, big telephony switches. But today, SIP is in a lot of devices. It's even in phones and things like that.
So to break it down for our listeners, what you're actually talking about is originally telephone systems. Make a call, you were actually going through the system. The system would create the connection between two phones. Let's talk wires for a second. You go through a central office switch, and you'd actually have a talk path through the switch to the phones. And I think what you're saying with SIP is, with the internet, all you had to do is know what the locations of each party were. And what SIP was doing was actually saying, well, we know where the locations are. Let's just get them to talk to each other.
Yep.
Right? Instead of through the system. So your voice over IP telephone switch then isn't passing audio per se. There might be a piece of it that's a gateway to the public switch telephone network, but really all of the SIP server is doing is mediating connections between devices. Would that be the right way to say that?
Yeah, it's sometimes called a rendezvous protocol. It allows intelligent endpoints on the internet to discover each other, negotiate capabilities, and then establish media sessions, whether it's voice, video, or screen sharing, things like that.
Right now, so we're using Google Meet right now and Skype and Zoom, and they probably all use a theme and variation on something that probably once looked like SIP.
Sure. And actually, this technology we're using right now is called WebRTC, which stands for Web Real-Time Communications. And that kind of came after SIP, but I had some hand in developing that too. I'm not a co-author of any of the key specs for that.
Oh, so you're not getting residual checks every month for the billions of people that are now using WebRTC?
No.
Okay, well, that's okay. I mean, you'll be remembered for changing the world.
No, I mean, it's amazing. These days, it's hard to imagine not being able to just communicate using the internet on any device. But if you go back 30 years, that was a really radical notion. And a lot of very smart engineers were shaking their heads and saying, there's no way this will ever work. Fortunately, we proved them wrong.
So you touched on it briefly, but let's just talk a little bit about what's the current rig at KU2Y right now?
Well, so these days I'm the trustee for W3YP, which is Villanova University Amateur Radio Club. So that's really the station that I use these days. I live in a small place in the city. I do set up temporary ground stations on my balcony, like I did last week when we launched our high altitude balloon from campus. But I just set up temporary portable operations for myself these days.
So from W3YP, I'm assuming as a trustee, you've also had some influence on the purchase and manufacture of the station there. What's the station there?
Sure. So we have a ICOM 7300 and ICOM 9700 are two rigs, and we have M2 antennas on the roof with azimuth elevation control. For HF, we just have an end-fed dipole for that. We don't have anything too fancy for HF because we primarily do satellite operations. One of the things that we enjoy doing is there's a event called 13 Colonies that happens over the 4th of July week here in the U.S., and it's basically American history themed, right? The original 13 colonies of the U.S. And so there are special event stations set up for each of the 13 colonies, of which Pennsylvania was one of them. And they operate, and people try to get they try to get a sweep to try to get all 13 colonies. And in addition, there's 3 bonus stations. And one of the bonus stations is one that operates from Philadelphia. It's WM3PEN, which kind of looks like William Penn, who was the founder of Philadelphia and the founder of Pennsylvania, that's named after him. And anyway, so a local radio club here operates the William Penn bonus station, and Villanova operates the satellite piece of that. So for that 1 week, we're the desired station on the satellites. We're the Fox for that, which is a lot of fun, especially for the students too. To be able to just call CQ and to get a pileup of people trying to contact them to get the bonus stamp on their 13 colony station.
Do you have a sense of how many of your students become amateur radio operators as a result of the Cubesatsim project and all the other stuff that you do there at Villanova?
A few have. I think I totaled it up. I'd say like 13 or 14 students so far in the past few years have gotten their license. But it's been almost a year since I've had a student pass the test. So it's not easy. College students have a lot of other distractions, and having an amateur radio station on campus means they don't, strictly speaking, need it. Like for our balloon launch last week, we used the Villanova call sign for it. So it's not like they had to get their license, in order to launch the balloon with the amateur radio payloads on it. But yeah, it definitely happens. It's a lot of fun when students get their license.
I understand that students might be busy and they might have competing recreational activities in college, but are they the opportunity for getting new hams on the air? It seems to me that you have hundreds of students that could go through your program every year.
Yeah, I mean, certainly these days a lot are exposed to amateur radio through what we do, and maybe some of them will become hams later on when they're not quite as busy and not quite as focused on getting good grades and the like. But I don't know. It's back when I got my license or whatever, one of my motivating factors was to be able to talk to hams in Australia when I was living in New Jersey. And I used to get up at 4 a.m. because that's when 20 meters was open, and it was 8 o'clock in the evening in Melbourne and Sydney, and I would just talk to hams and enjoy it. These days, unfortunately, with the internet, it's so easy. It's so easy for people to communicate. They don't need ham radio for that. But the ability to experiment and to do a lot of interesting things with ham radio is something. They all have phones, so they all have radios in their hands, but they don't know anything about it. And so when I'm building transponders and transmitters and things like that, it can be interesting for them, but it's definitely a challenge. And having the need to study, and to learn regulations and things like that. It's just not easy. And you have, in a sort of club setting, you have students for 1 hour per week. So what are you going to do for that 1 hour?
Alan, do you have a sense that younger people now, I'm an older person, so now I'm trying to understand younger people. I have grandchildren. I'm trying to understand them too. That there's a separation between vocation and avocation. If they're choosing their vocation to be an electronic engineer, a radio engineer, microwave engineer, a satellite engineer, do you think that they see that taking that home as a hobby is maybe an onerous kind of problem rather than an opportunity for tinkering in the workshop late at night?
Yeah, I don't know. I mean, I think it's sort of personality, and those that are interested in being hands-on, will be. So we have a senior design project, right? All our seniors, before they graduate, they have to do a design project. It's multi-semester. They have to come up with it. They have to spec it out. Then they implement it, and they report back on what they do. Most students do software projects. They're electrical engineers, but most of them do software. And, a small percentage of them do hardware. I have students that, build things and design circuit boards and the like. But I don't know why that is, I mean, software is fun. You can do a lot of things with it. I think also hardware and, doing physical things, it can be difficult. It's complicated, right? I mean, radio is really complex, and if you're saying I'm going to design something and build it and test it and it's going to work, right? That's a lot of steps. That's a lot of things that you're committing to do versus, I'm going to write some software and it's going to do this, that, and the other thing. So I don't know. I'm not sure that everybody is that interested in sort of, taking on the challenges of hardware and designing circuits and really getting deep into the technology, and having a software option these days, I think it's the option most electrical engineers take.
Really? So that means that they can just about build everything, even I guess with circuit simulators now, things like that, SPICE. I guess we're way beyond SPICE now, but they could build just about everything without ever having to lift a soldering iron.
Yep.
And even test it out before it gets there. How good is that stuff now? How good is that technology for simulation?
It's pretty good. I mean, obviously we still have labs and students have to do things. And even thinking back on my own education, we did not look forward to our labs. They were always so difficult. Things always went wrong. You'd plot your graph and your data would go like this and it's supposed to go like that. And you'd be like, why? And I don't know. It's it's pretty common.
Well, I guess, from the olden days, there's nothing like working with high voltage and getting the bite, things going up in smoke. I still blow things up in my lab. I'm usually kind of embarrassed and grateful the wife isn't home as I blow all the breakers in the house. But it's usually because I forgot something quite obvious. But I still think that the hands-on part, especially when there's blood left in every project or a third-degree burn on your thumbs because you weren't careful, I think those are all part of the hobby. The smell of burning flesh is something you don't want to get used to it, but you recognize it when it's happening.
Sure.
What most excites you right now about amateur radio?
Well, I guess probably the most fun I have these days is with high altitude weather balloon launches. That's something that I've been doing with students lately, and they get really excited about it, and it's a fun project that it's kind of like a small space mission, but it's done over a couple of months and it costs a couple $100. But it has like all the elements of a space mission, but it's all over with quickly. And it's in your control too. It doesn't have launch delays and all those kinds of things. But yeah, because we just had a launch last week. We sent our payload up to 100,000 feet, just over 30,000 meters, and then we retrieved it as well. We basically tracked it using our trackers and picked it up off the golf course, and we were transmitting live slow scan TV images, APRS packets. We flew a reprogrammed radio sonde. It's a lot of fun. The students enjoy that, and frankly, I enjoy it these days too.
So I was about to ask you what your favorite electronic package is for high-altitude balloons, but it sounds to me like you took a National Weather Service radio sonde, is that what you said, and repurposed it for ham radio?
Yeah, that's one of the ones that we use. Yeah, there's basically the RS-41 radio sondes that are used by the National Weather Service here in the U.S. They fly hundreds of them a day, and you can track them on public websites. And hams retrieve them, and then you reflash the software so they transmit on amateur radio spectrums. And the hardware is amazing. The GPS is great. You get a tremendous lock on the signal. And we've had really good results of those. The other payloads we fly are modified Cubesatsim boards. So we boost the power. We get rid of all the extraneous things that we don't need. But we use the same boards that we use in the CubeSat simulator, and that way we get some more experience with them as we fly them up to the edge of space.
Well, that's pretty amazing. So the National Weather Service relies on people that know how to track their radio sondes in order to clean up the environment, per se?
Well, yeah, I guess in the old days they wanted them back, but these days it just says if you find this, throw it out.
Oh, really?
Yeah, they don't want to. I mean, they gather the data from the transmission, basically.
I mean, I frankly have never seen one. One has never fallen near me. Given that there's, hundreds of these that are launched a day across the world, you would think...
Thousands across the world, yeah.
Thousands across the world. Yeah, it's pretty amazing, isn't it?
Yeah.
What advice would you give to new or returning hams to the hobby?
I don't know. I mean, it's there. Ham radio has so many aspects to it. And the technology these days is pretty interesting. It can be a little daunting when you get started. For instance, I remember it was probably 5-6 years ago when I first got involved with SDR, with software-defined radio, and it was a little frustrating at first. I remember getting my first RTL SDR and installing the software, and I could not get it to do anything. I could not get it. It was just silence, okay? Because it turned out there was one little button you had to push. And if you didn't push this button, the software just sat there and did absolutely nothing.
So the button's on the RTL SDR?
Well, it's in the software.
Oh, it's in the software. Oh, I see. Okay. The start button.
Yeah. I don't know. I mean, when you turn on a radio, it turns on, right? I mean, it makes noise.
Right.
And you hear the static, right? Software-defined radio software, you run it, it does nothing. It does nothing by default. You have to actually find the right magic clicks, and then you'll hear the beautiful static. Then you'll see the waterfall moving, and then you need to find the gain, because if your gain is at 0, you'll hear static but nothing else. Then when you find the gain, you're like, wow, okay, now there's signals. So I don't know. I guess my advice would be to not be frustrated when you're trying new things, because it can take time, and things, when you're dealing with technology, things are a little bit complicated, but you just need to stick with it, and it'll be worth it. But find something that interests you. There's so many different areas of ham radio these days. There's probably one part of it that will get your interest.
Well, I think that's an amazing note to end the conversation on. And I'm so grateful, Alan, that you decided to talk about what you're doing about Cubesatsim, which is a new thing for me. I'm, again, grateful and wish you 73, and thank you so much for coming on the QSO Today podcast.
Yeah, thanks, Eric. 73 to you, too.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Alan. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in KU2Y in the search box at the top of the page. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any of the episodes into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing on the subscribe buttons on the show notes page. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes pages. Your value for value support is recognized on the QSO Today podcast and in the weekly show notes. Use our Amazon link when you shop on Amazon. Clicking on this link before you enter Amazon will allow Amazon to pay us a small commission on what you purchase. This is a very painless way to support the QSO Today podcast. QSO Today is syndicated on every podcast platform, including Spotify and the iTunes Store. Until next time, this is Eric for Z1UG 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.